Hi, all. Welcome to the Riot Lunch and Learn series, the place where we highlight Riot sponsors and partners. My name is Jen Morgan, and I'm the Virginia program lead for Riot. Just a couple of quick reminders before we get started today. This event is being recorded and will be posted to Riot's YouTube channel, as well as the meetup pages where you registered for the event. If you have any questions throughout the presentation, please place them in the chat. We ask that you please place the questions in the chat so that they can be read aloud for those watching later at a later time. All questions will be read either during the presentation or at the end, depending on the topic of the question and where we are in the presentation. And then finally, please keep yourself muted throughout the presentation to help mitigate background noise. With that all being said, today we have the Blues team here to present how to accelerate your IoT with these open source starter apps from Blues. TJ, I will turn it over to you.
Awesome. Yeah, let me bring this up and move some things around in Zoom. And yeah, thanks everybody for joining us. We're going to be talking about accelerating the IoT with open source starter apps, which is a really fancy way of saying we're going to be building some projects, doing some demos, and we should have a little bit of fun. So I'm TJ Van Tol. I work as a developer advocate at Blues. With me, I have Paige Niedringhaus and Hayden Roche, software engineers here at Blues as well. And we're going to be round robining, tackling some of these projects, some of these demos, and hopefully giving you some inspiration for some of the stuff you might want to tinker with, try out, or build for yourself. If you do have any questions as we're talking here today, feel free to drop them in the chat or the Q&A here in Zoom. One nice thing about having multiple people here is that the two of us that aren't talking will be available to help answer any questions that you might have. Now, specifically today, what we're going to do is start by, I'm just going to give you a little bit of a background at what it is we do here at Blues, why we built these projects, which we call accelerators. And I'm going to try to go through this or try to keep this somewhat brief because I want the lion's share of our time today to be spent on demos and so that you can see some of these projects in action, because if you're like me, that's the best way for me to learn. But I do want to give you a little bit of background on who we are at Blues and what we do, because I think it'll give you some context to understand some of these projects. So at Blues, we are a company that exists to try to make IoT easier for developers and just more affordable for everyone. So we do this by helping you take your data and securely transferring it from the device to the cloud. And we do that by building some low power, zero config hardware. And you'll see some of this in action as we go through these projects. And really, and I think most importantly, really core to what we do is providing an unmatched developer experience. We are all developers here at Blues from top to bottom, and building a really nice experience for you all is kind of core to everything that we do. Now, the primary piece of hardware that we use and something that all of our accelerator projects build on top of is the Notecard. The Notecard is a low power system on module. And it's a module that's really designed to make connectivity really, really simple. And that connectivity can be cellular, it could be Wi-Fi, or it could be LoRa. Now, the cellular Notecard is our most popular Notecard because it comes packaged with 500 megs of data and 10 years of service built in. And what's cool about this is that there are no subscription fees associated with the Notecard. You don't have to sign up for a cellular provider. You don't even have to work with a cellular modem. The Notecard abstracts all of that away for you with a very simple API. The way the Notecard talks is JSON. So you, again, don't have to interact with a cellular modem when working with a cellular Notecard. Instead, you're sending JSON commands to work with the Notecard. And under the hood, the Notecard is taking care of all of the interactions with the cellular modem and getting your data to the cloud. Now, the API for the Notecard is JSON-based, but as you're going to see, we also have firmware libraries available for Python, Go, Arduino, C, C++, Zephyr, as well as a few others that are just designed to help make it easy, again, for you to connect to the Notecard and send the commands to get the projects you need to get built. And I think we're going to be looking at the Python and Arduino ones today as part of our examples. If you need just a simple way of thinking about the Notecard, just for understanding these demos, you can think of it as a device to cloud data pump, basically just some way that you can get data from your app and up into the cloud. The Notecard knows how to talk to a cloud service we have at Blues called Notehub. And the Notecard really, just by one command, you can connect your Notecard to Notehub and start instantly sending data. The full flow is going to look a little something like this, and this is something that really all of our demo apps are going to do. Everything starts with some sort of host. The Notecard is host agnostic, so you can bring your own host. You can use some that we make at Blues. You're going to be seeing some examples with some STM32 based microcontrollers, some with a Raspberry Pi. Some of our other accelerators use like ESP32 hosts and whatnot. Regardless of what host you're using, you need to get JSON ready to send to the Notecard. And this is where you can either just work with raw JSON or use one of our firmware libraries. You send that JSON to the Notecard. The Notecard then can securely transfer that data over cellular, Wi-Fi, or LoRa to our Notehub cloud service. And then the data can then be transferred via JSON to whatever your end destination is or wherever you want your data to live. And that could be really any cloud. It can be one of the big clouds like AWS or Azure. It could be a dashboarding service. It can be, you can just send the data over HTTP or MQTT. You could send alerts. You'll see some of our projects really only designed that the only thing you want in the cloud is some sort of an alert when some sort of condition comes up. Hey, the temperature is too high and I need to know about it. Hey, the powers went out and I need to know about that. Notecard is really great for those types of solutions as well. Last thing I'll show is that the communication with the Notecard and the cloud is bidirectional, meaning you can send data back down in the opposite direction. The reason you might want to do this is there's really two primary use cases. The first is syncing settings of some sort, something we call environment variables, and you'll see some examples of this today. If you have a fleet of devices out and you have, like, let's say, an interval at which you're taking readings and you need that to be synced across devices, you can use Notehub to sync these values and push data down to the device. The other example is when you need to send basically like commands down to a device. So imagine you're building a project where you need to turn a light bulb on and off over a cellular connection. You could build a mobile app that had a button. The button could then talk to the Notehub API that says, turn the light off. It can push that note down to the Notecard, which can tell your host to actually do the work to basically toggle that light on or off based off the command. Overall, the long story short of the last few minutes is that the Notecard is designed to make connectivity, which is usually kind of one of the harder parts of building an IoT project, to make it really simple. And once you have connectivity being really, really easy, it makes a lot of things possible. And that's really where the Blues Accelerators came into play. We wanted to show a list of really common or useful projects that you can build sort of in the IoT and embedded space and show how you could build those with Blues technologies. So if you're the type of person who likes to multitask or just look around, I'd highly encourage you to go to blues.dev/accelerators. This is a listing of all the projects we have out there. There's something like 40 some of them today and counting. All the ones that we're going to be demoing are there. You can also just peruse. It's kind of a fun list to look through. You might find something that is related to something you want to build or something that you can take some inspiration from. What each accelerator actually is that it's first and foremost a complete walkthrough of how to build a project. So there are full instructions on how to build everything. Each accelerator is also going to list all the hardware that you need. So it's going to link to the appropriate shops and stores so that you have a clear list of everything you need to get. The ones that have firmware, all the firmware is open source and liberally licensed. It's all Apache 2 licensed, so you can take it, and the last bullet here, you can copy, fork, build upon it, whatever you need to do. And all of them provide some way of viewing your data. So some of them are going to help you build a dashboard. Some of them are just going to help you get the data to the cloud. Some of them are going to show some alerts. The first one I'm going to show off here is going to do some alerting, but all of them provide some way of showing you how to work with your data and build something useful. So that's like the quick whirlwind tour of everything Blues and everything the Notecard. If you do have any questions, if any of that wasn't totally clear, again, I'd encourage you to go to the chat or the Q&A to ask questions. But I'm also hoping that since it's now my favorite time of this, demo time, that hopefully by seeing some of this in action, things are going to be a little bit more clear. In terms of demos, we have 6 of them. So the 3 of us here are going to sort of round robin show this off. It should be fun. Hopefully some of these things are going to be pretty interesting for you to see. I'm going to get things started by showing off a power outage monitor. Now, I picked this one because the accelerators tend to vary in terms of difficulty level, I would say. And the power outage monitor I like starting with because I think it's the simplest of all the accelerators, partially because the requirements for this project are really straightforward. The idea is this is a project that you want to build so that you know when power is, basically when power fails and when power is restored to a device. So specifically, I have a device, I'm going to plug it into the wall. I want to receive a message when power goes away, and I want to receive a secondary message when power is restored. So with that context in mind, I'm going to just bring up my desktop, and I'm already at blues.dev/accelerators. And so what I'm going to do is search for power outage so I can find this project, the power outage detection. You'll see it has this list of hardware, and it's got a link to the full instructions, which are on GitHub. So I'm going to go and head over there. If I scroll down a little bit, I'm going to go back to this hardware list real quick and talk about this in a little bit more detail. So first and foremost for this project, we're going to need a note card to provide the connectivity part of this. We're going to use a cellular note card for this one because if you think about it for power outage, if the power goes out, usually the Wi-Fi goes out as well. So you need something that's going to work without power being available. I've also got a note carrier on this hardware list. So note carriers, and I'll just open up the note carrier A here, are development boards we provide that allow you to slot in a note card and then also provide a variety of developer conveniences or prototype conveniences. So on this one, we're going to be using two features of the note carrier for this demo. The first is just this micro USB cable that's going to provide power. So power, this example is we're just going to basically take a USB cable, put it in a little wall outlet, or in this case, I'm going to use my laptop to power this so that this note carrier has power. And secondarily, there's a JST connector over here for a LiPo battery. So when the power goes out, whether we rip the cord out or if the utility company cuts my power, the LiPo battery will provide enough power to keep the note card going so that it can send these alerts out that, hey, power left, and then eventually when power comes back to the USB, it can send that secondary notification that power has come back. So I've got all this on my desk. I'm going to hold it up just momentarily so you can see it. I've got a note carrier A with a cellular note card within it, and I've got a LiPo battery hooked up as well. And that's what the hardware looks like. In terms of what you actually need to do, because this project is so easy, there's actually only two requests you need to run on your note card to set everything up. The first is a request called hub.set. So notice that this is JSON, so communicating with the note card is done via a JSON API. You can use this JSON API basically through some of the firmware libraries that we offer for talking to the note card, and some of the later demos are going to show that. But this project actually is so simple, it doesn't even have a host microcontroller, and we can run these commands on the note card directly using a tool that we have actually built into our web browser that we call our in-browser terminal for interacting with the note card. So I can actually just open this, connect to this note card. So I've got the USB cable that you saw just hooked up to my note card. I can connect to this, and then I can take the command that we saw and just directly paste this in. The one bit I need to change, if you look at this product, so this is a unique identifier for the project that I have in Notehub. So note the note card, the hardware on my desk, knows how to speak to the cloud service, Notehub, which is a free to sign up for service at notehub.io. And each project that you create here has a unique identifier so that the note card basically knows when it pushes data up, what bucket or what project to put that data into. So I need to grab this identifier. I need to paste it in for my product and run that. The second request I need to run, if I scroll down a little bit, is this card.voltage request. This is going to be the core of the magic that's happening for this app, because this is a request on the note card that just tells it that every time the voltage, specifically the USB power, changes, to send an alert, which we'll look at what that looks like, and sync that alert right away. And so I'm going to run that. And at this point, that's actually all the hardware and all the setup that I need to do. I now have basically a fully capable power outage detector. The only thing I need to change from here is that once all of this is configured, the Notecard's actually automatically going to start sending data up to the cloud. And if I go to this events list, you can see some examples of this when I was playing a little bit earlier today. Essentially, I'm going to be getting these messages that power turns on or off in my events list. The last piece of the equation is that you then want to take these events and use a Notehub feature called routing. If you think back to my diagram where data was flowing across, this is the last piece where you take the data to the service that you ultimately want the data to end up with. If you follow the instructions, the data, it's basically going to help you set up a route to Twilio so that you're actually getting SMS messages when power basically is taken away or provided to your device. For this demo, I'm going to keep things simple and use a little service I like called Webhook. Webhook just lets you stand up an endpoint and then post requests as they come in. So what I'm going to do is I'm going to take my device, hold it up, and we're going to yank the power. We can pretend this is at like a cabin or some facility and power just went out. So USB's power has been cut. And so what the Notecard's then going to do, it's going to take it a second because it's going to fire up its cellular modem. It's going to get a note or an event ready. And then within about a minute or so, what we'll see is an event in this list that's going to say basically something like this, that the USB power is out. And we should see that here within a second if I refresh. And then what Notehub will do is then forward that, or basically route that data out to whatever routes that you have configured, which in this case is Webhook. And if we had Twilio provided, then it would also send out an SMS as well. So I'm going to give this one more second. I see my Notecard is working. I don't have a very good antenna on this, so it might take a second to get it out. And what we should see is a request coming through here. There it goes. So power has failed to my device. It's called your serial number because I took and directly copied and pasted this. Probably in a real demo, you'd actually name your device. But power has failed. And so what I'm going to do is plug this back in and do that. And then what should happen is within a second, this one should go a little bit faster because it's already sort of formed that connection to the cell tower. And then I should get a secondary request that comes here in a second. But hopefully, as I would give this a few seconds to come through, hopefully you can get a sense just even off this simple example of what the Notecard makes possible, just make connectivity really easy. This was a Notecard that essentially was factory reset. That's all you have to do out of the box. There's no additional setup, just run those two commands. And I've got something that I could toss out there and basically provide some power. And I think that's the first demo. So we're gonna round robin this. I'm gonna jump into the chat and check things out. And I think Paige, you're taking demo number 2.
I am. Thanks, TJ. So, hey, everybody, I'm Paige Niedringhaus. As TJ said, I'm a staff software engineer here at Blues. So I work primarily on the software side of things, which means building web apps, helping with our developer documentation and things like that. But it has been really fun to be part of the teams that have been building these web apps to go with some of our accelerator projects. So the first project that I am going to be sharing with you today is a cellular connected electronic kiosk. So if you think about maybe when you're at an outdoor shopping mall or you're in a doctor's office or riding in an elevator, perhaps, you've all seen those television screens that are typically on walls or at big stands where you can go, maybe you can touch them and interact with them, and they just have some kind of carousel of interesting information, sites, things to check out, stuff like that. So we wanted to be able to do the same thing, but without having to potentially connect those types of kiosks to Wi-Fi because either Wi-Fi is not available, it's spotty, or for security reasons, it's just not something that's really accessible and doable. So I was able to do this with a Notecard and a Raspberry Pi. So if we scroll down, I'll play this video for you shortly to show you how everything works. But if we talk a little bit first about the hardware, a simple Raspberry Pi 4 that is available at any electronics store. We have a note card, which is the same kind of note card that TJ was using, and the note carrier Pi hat. which is another type of product that Blues sells. So I'll give you a quick view. This is the Note Carrier Pi hat. This is where a note card would slot right into the top of it. And then it's able to connect. It has a couple of different on-off switches and some JST connectors, but it slots right on top of any note carrier, or sorry, any Raspberry Pi. So with that, and we did a little touch screen, a touch display screen to kind of demonstrate how it could work. I have a wireless keyboard and mouse that I used to control it, and a couple of extra micro USB connectors to kind of wire everything together, but basically a working example. So if you scroll down a little bit farther, you can see exactly how the Pi hat slides right on top of the note carrier, or sorry, the Raspberry Pi. You can see that there is a note card that is connected right on the top. Its little antennas are connected right there, and it's all encased in this touch screen. So I'm going to scroll down just a little bit more so you can see a couple of other versions of how it's connected to the touch screen, and then keyboard and mouse. And then we get to actually connecting it to a Notehub project. So very similar to how TJ created a project for his demo, we would create a project in Notehub that was for this cellular connected electronic kiosk. And we need to do a couple of extra things for this. So the idea is that with Notehub, you would have multiple kiosks that would potentially be receiving the same data and potentially updating those kiosks as time went on, whether it's new promotions that you have or just things that you want to change. So for my demo, I only have one device, but you could potentially have tens, hundreds, maybe even thousands of these devices. And the way that you actually send them new data and let the kiosks know that there is something for them to download is by using fleet environment variables. So if we click into this device in particular, and we head over to the environments tab, we can see that there are no device level environment variables, but there are fleet level environment variables. And these are telling us where the zip file is that this kiosk should be downloading. They are telling us the content version, which is one way to actually update and tell the kiosk that it needs to download some new data because the content version has changed. We have some specific kiosk data, which I'll go into more in depth later, but it is a very simple array of different cities because my kiosk demo is a weather application that is fetching data for these particular cities and displaying it. And then we have a kiosk download time. And this is set to now so that things will immediately update when something has changed. But you could also set it to a particular time. Like if you know at 2 a.m., nobody will be using these kiosks and you want it to go out and check if there's new data, they could all check at 2 a.m. Central Time or what have you, because it does take a few minutes to actually complete the download and run the new script or the new data that you have to show. So that's part of it. And then the other part is actually routes. And if we go over here, we can see this is how we will get any new content that is available for the kiosks to download. They will come in through routes. So I'm simply connecting to an Amazon AWS S3 bucket where I have pushed the software that I want this kiosk to run. But you could have it anywhere that is available on the internet, whether you're using GCP or Microsoft Azure or something. You just need to have it available. And then you can say to the Notehub project, this is where the information should live. So go out and get it. So if we come back over here, we talked a little bit about the environment variables, and I briefly covered those. We talked just a little bit about the fleets. And then we also have some Python scripts, which will be downloaded directly to your Raspberry Pi, which will help set up, this is the Note Carrier project, or this is the Notehub project that I am connected to. And this is the name of the file that I should be downloading. And we also have the sample web app. So since it's very difficult to show a screen live on another screen or on a video, I will show you a video that I made that kind of demonstrates this pretty well. So we'll go full screen on that. Now, this is actually a screenshot of my 7-inch Raspberry Pi that's running inside of this little computer. And if you look down here, this is the Python script that I've downloaded, which is available on GitHub. And I have just put in some simple command line setup. So I'm telling it that it's the connected kiosk data. I am giving it my product, which is my Blues Notehub URL, telling it that this is the name of the Notehub project that is going to be connected to. And then I'm telling it the route that I want it to look for data from, which is the kiosk route. So all of this is available, like I said, on GitHub, so you can check it out in more detail later. But if we start playing the video, I will start the script running, and we will see very quickly that it actually runs and it brings up this little connected kiosk. And it just shows us the weather in different parts of the world from a simple weather API. And if we want to change that, we can. We just simply go to our Notehub project. We scroll down to our environment variables, and we can actually change the list of cities that is being shown by the kiosk. So let me back that up just a second. We can see that previously the cities were places like Los Angeles, Tokyo, Munich, and I have pasted them and replaced them with New York, Paris, and London. So I go ahead and I save that change. And when we come back over, we can see that the script is running and it is writing new data. It's realizing that the cities that it is displaying in the kiosk have changed. So it pulls that data in. And when we head back over to our kiosk, we can see that in a second, it's actually going to update and it's going to change and show the new cities that have been pushed to it. So we scroll through, we go to Tokyo, we go to Munich, go to Mexico City, and then we see that it switches over, and now we have Rome, we have New York, we have Paris, and we have London. So this is pretty cool, I would say. It's very nice that depending on how much things need to change, you might not even have to push a new data file up to the cloud. But if you do, you can always, like I said, tell Notehub and the Notecard that things have changed and it needs to download new data. But there is even the potential, depending on how much you need to change the data, that you might be able to just change an environment variable and have that affect the web app that you have running on your kiosk. So that is another example of how you can use a note card, a Raspberry Pi, and a regular Python script to potentially program a pretty useful little web app to go with it. And there is no Wi-Fi required. It's all cellularly based. And with that, I will stop sharing my screen and I will turn it over to Hayden for his first demo.
Yeah. Hi, everyone. I'm Hayden. Hopefully you can hear me okay. I'm also a software engineer here at Blues. I primarily work on firmware and lower level things. I've spent a lot of time working on these accelerators. And the first one I'm going to show you today is, I believe it said audio classifier in our table of contents, but we had a last minute change and we swapped that one out. If you're interested in the audio classifier, it does exist on our accelerators page, and it's a machine learning based binary audio classifier that can pick out a particular sound in the environment and publish the detections to Notehub, and then route them on to your cloud of choice. But the one we decided to swap it out for is Controller Area Network Vehicle Monitor, otherwise known as a CAN vehicle monitor. So let me go ahead and share my screen. Great. So this is the page for the CAN vehicle monitor. So if we have any automotive folks in the audience or aviation folks, also industrial controls folks, you might be familiar with CAN, but it's essentially a bus that was developed for cars, trucks, what have you, to allow all their ECUs or electronic control units to communicate with one another and save wiring, essentially. So CAN is in every modern car, and all the little computers, dozens to hundreds, depending on the model of car, are using CAN bus to communicate with one another. So there's a lot of valuable data being tossed around on a CAN bus in your car. Wouldn't it be great if you could do some telemetry and actually get that data off of a car and into the cloud, analyze it, and what have you? So that's what we've done here with the CAN vehicle monitor, leveraging a Notecard as the data pump to the cloud. So here's our typical bill of materials for this guy. So in this demo, I'm going to be using my laptop is going to act as one node on the CAN bus, and then I'm going to have a host MCU connected to a Notecard as another node on the bus. And so that node will essentially act as a bus sniffer, sniffing the traffic on the bus, identifying packets of interest, and then forwarding the data in those packets to Notehub, where it can be consumed by whatever services you want to configure. So in this particular demo, we're going to be using an Adafruit Feather M4 CAN Express, which uses this part from Atmel. It comes with a CAN transceiver to establish the CAN bus connection. That's what you're seeing right here. And then here's it with the pin soldered on. And so let's scroll down a little further here. This is that part actually seated onto our note carrier F. So the note carrier F is another one of our note carriers. We've mentioned the note carrier A and the note carrier Pi so far. So the F, if I'm not mistaken, stands for Feather. So Feather is a form factor that Adafruit created, I believe, that several different microcontrollers support as a standard pinout. And you can basically slot any of these Feather PCBs onto the note carrier F and establish I2C and serial communication with the note card. So it makes it super easy to just take any of these and work with them. So we have our own Feather called Swan, which is an STM32 based Feather that you can plug in. Again, I'm using an Atmel part here that has a CAN transceiver. Here's an NRF Nordic Feather that has Bluetooth and all sorts of good stuff on it. That works as well. So there's a lot of these out there. So this is a USB-C connection, providing power and serial monitoring capabilities of the MCU to my computer, so you can see what's happening on the device. And these two wires are actually all that's needed for the CAN bus. So it's just CAN H and CAN L, high and low, differential signaling. And data will be exchanged between my laptop, which is using this USB to CAN converter, to send packets out on the bus. And again, those packets will be filtered. We'll pick out packets of interest, and then they will get sent out over cellular, over this antenna to Notehub. So there's a couple environment variables, actually just one in this case, of interest. So if I go over here and I look at my Notehub project, and I go to the environment variables for this particular product, CAN vehicle monitor, you'll see there's an IDs environment variable. And so each CAN packet has an identifier along with a payload of data. And the format for this environment variable is just hex strings of digits delimited with semicolons. So each little token here represents an identifier. So those are the identifiers that we'll be interested in. If we get a packet that has a different identifier than what's in this list, it'll be dropped. We don't care about forwarding that. If we get a packet with one of these, we'll go ahead and forward it to Notehub. I'm going to switch over to my terminal now. So this is a serial monitor showing what's happening on the MCU. This is just periodically checking for environment variable updates. But more interestingly, if I go over here, I have a script that comes with this firmware project. Again, this is all in GitHub, and it uses just a little bit of Python to send a packet with the data specified in this data parameter. In this case, just 123, 3 bytes. And here I specify the ID ABC. If you remember in our list, we have ABC listed as one of our identifiers of interest. So let's go ahead and fire that packet out on the bus. And if you look over here, you'll see some logging that says received extended packet with ID ABC. That ID matches our filter list that I just showed you. There's 3 bytes in the packet, and it went ahead and added it to this note file data.qo. And then it said, sent the data to Notehub. So if we go look at Notehub, we go to the events, you can see 10:35, that's my time on the Pacific coast. You can see the packet 123, 3 bytes in length, and then the ID is 2748, which is just ABC in decimal. So this is a really straightforward way with just a tiny bit of firmware and a little bit of Notehub config to get data off of, a vehicle or a machine in a factory that otherwise had been isolated to its particular network or no network at all. And then, you could do all sorts of interesting analysis. You could even push data back, in theory, to the vehicle, put that on the CAN bus. So the possibilities are really endless with this sort of thing. And we also support the same sort of concept with other buses. You might be familiar with Modbus. It's a popular industrial protocol that's been around forever. It's used in all sorts of factory settings. We have a Modbus accelerator that shows you how you can control read and write values to these machines over Modbus using a Notecard as well. So that's it for the CAN vehicle monitor, and I'll be back around to show you another machine learning application for those of you who were hoping to hear about the audio classifier. I'll have something to whet your appetite soon. So thanks.
Cool. Yeah, and then I'm going to bring up the next one. It's cool because as we're starting to go through some of these projects, hopefully you're seeing some patterns. And I think one of them that I think is cool is that we're not talking about the connectivity at all. That's the one cool thing about using the Notecard, is that's kind of like the assumed easy part of how the data actually transfers. And usually if you've built some of these things before, oftentimes that's the hard part. That's kind of what makes me excited to work on some of these things. But I have another app to show. So this is going to be number 4 out of 6. And mine's easy to find on the page because it's right here in this top left slot, the indoor floor level tracker. So I'm going to bring up the instructions, and I'm going to scroll all the way to the bottom of this to start because I just want to focus on the hardware first. The setup is going to look pretty similar to what Hayden just showed for the CAN bus project. This is a note card, a cellular note card, again, a note carrier F for having a feather compatible microcontroller and the Blues Swan in it. One thing cool is that these 3 pieces of hardware, as well as this antenna attached to it, are available in a Blues starter kit. So if you are interested in trying any of this, the starter kit is kind of the easiest on-ramp because it's with it you can build a whole lot of the projects that we are talking about today. For this project, the one thing in addition to the sort of standard Blues hardware setup we have is this sensor up here, which is a BMP 581 barometric pressure sensor. Because the idea behind this floor tracker is that by measuring barometric pressure and seeing how it changes, because pressure will change based off altitude, you can kind of approximate the floor or essentially the height a person or an asset is within a building. So this project is going to have firmware that continuously monitors the pressure from this sensor, and the firmware is going to do some stuff to essentially help you build a dashboard that looks a little something like this. The idea being, if you are an emergency team and you're responding to some sort of event at a building, you could have a bunch of these devices in a little enclosure. Everybody could strap one onto their belt, turn it on, go into the building, and then the person on the ground who's coordinating the team could bring up something on a tablet or a phone or whatever that's tracking people throughout the building. It's seeing approximately how high they are. throughout the building. Perhaps it could be monitoring other conditions as well, maybe temperature or something else that you wanted to track. So this project also has firmware. It has some Arduino-based firmware that's going to be working on the Swan. The thing I want to focus on for this project is that for this one, we actually have a fully featured web application for building the dashboard that is also open source and available. And I have it running over here. What this is going to do is by default, just list all the devices that are associated with the project. And if I bring up Notehub real quick in my indoor floor level tracker, I have my device over here. The other thing kind of cool about this project is that there are two different modes built in that the firmware can operate in. If you think about this project, and this actually applies to more than just this floor tracker, but most of the time when this project is running, you don't really need to be getting much data. If the device is just idling, you don't want to be using up battery, because battery is very important when these devices are actually in go mode and you're like really need data to be flowing out pretty quickly. So what this project does is it has an environment variable on a fleet of devices for whether the devices are live. And when they are not live, the devices are sort of just idling at a really low power state. The Notecard actually idles at 8 microamps, so it can last quite a long time off of a battery charge. And this is an app that kind of has to run in a low power setting, because if you're tracking something throughout a building, you're not going to be plugged in. You kind of have to be operating off battery power. But what you can do is you can turn live mode on. Now, under the hood, this is an environment variable, and hopefully that's another theme you're seeing throughout the fact that you can take these settings and sync them across devices or even fleets of devices. Because if I go into Notehub for this project and go to the fleet, because the environment variable is on this fleet, the live setting is set on the fleet such that if somebody is on the ground and they're bringing up this dashboard, they want to make it live for everybody, the entire team, right? Not one device. They don't have to individually activate these things. They can turn them live. If new people turn on new devices, the first thing they're going to do is check Notehub for environment variable updates. They'll see that they're live and they'll be put into go mode as well. And once they're live, the device is essentially, the firmware is going to start taking far more frequent readings. You can see I've got them coming in here with different altitudes after I turn this thing in live. Now, this demo is not going to be super exciting for now because I'm just on floor 1. And as cool as it might be for me to like climb up on the roof of my house to demo how this works, we don't exactly have time for that. But one thing we do let you do is through another environment variable, we let you set the default floor height. So the firmware is doing some math to try to determine what floor you are on based off of your altitude. It takes a baseline pressure reading when it starts up and first gets put into live mode, and it does some math based off the altitude change. This is just a common default floor height. But what I'm going to do is make it a silly value for demo purposes so that I can change the altitude of basically just taking this thing on my desk and holding it up a little bit, which should change the altitude quite a bit if I've got a 0.1 meter floor height. And what we should see is, yeah, since this is in live mode and it's going pretty instantaneously, what do you know? I just climbed to floor 14. I can also check for voltage. There's a way you can configure alarms based off this project as well. And the reason I wanted to show you this one specifically is not necessarily the details of floor tracking, but just show you the sort of apps that you can build off this tech stack. Because what this is doing is under the hood, it's just using the Notehub API to pull data from Notehub. We also have projects that show how you can route data out of Notehub into a database and then query that database to build a web application. So if you are looking to build something a little more fully featured, we showed some apps that are just putting some data, like sending out a text message or whatever, which is fine for some simple projects. But if you're really looking to build a more robust thing for like a really solid solution that contains a full dashboard, that's the sort of thing you can build as well. And this is a good reference for that, even because I'm guessing most of you aren't dying to build an indoor floor level tracker, but you could picture this being temperature and humidity data or location data or any other data that's relevant to the sort of things you are building. So again, this project is the first on the list for the indoor floor level tracker. And with that, I'm going to pass it to Paige for the next one.
Very nice. Thanks, TJ. So I am going to be showing off another one of our featured projects, which is actually a flow rate and valve monitor control system. And this was a really fun one to build. It also includes a web app dashboard, and it has a note carrier F at the base of everything and a feather that is powering this whole application. So let's talk a little bit about what you need to actually configure in your Notehub project. Once you have created a project, as you would in any other, you're going to set a couple of environment variables. And these are fleet environment variables, again, because you might have multiple valves that you want to control and keep track of. So you're going to set 3 different environment variables. And I'll show you one of my devices, which has both fleet and device level environment variables, depending on what your use case is. So we have a flow rate alarm threshold max, and we have a min as well, which we'll use to keep track of the flow rate when the valve is actually open and water is flowing through it. And we also have a monitor interval. So this tells us this is how often the flow rate monitor should actually be taking readings and checking that the maximum and the minimum are not being exceeded in any way. So those are basically the 3 environment variables that you'll need for this project to make it work. And once we have set those, you will do some hardware. Much the same, you can use a Blues starter kit because once again, it all begins with a note carrier F, a note card, and a Swan microcontroller. And then for this one, since I was building essentially a tiny valve and flow rate project is the best way to describe it. There's a lot of very particular pieces of extra hardware that's needed. So we have a water flow sensor. We have a solenoid valve, which helps control the on-off of the actual flow rate valve. We have connector cables, silicon tubing, which is what the water runs through, a power breakout that helps supply the correct voltage to this valve to turn it on and off, level shifters, a MOSFET driver, which allows the Swan to switch from high power devices without needing to send that power from the microcontroller. So that's particular to the Swan, which is our microcontroller that we're using. And then we have a nice enclosure to kind of put everything into and some quick connectors to push water through my little example demo. Like I said, all of this is available. We have wiring diagrams. We have links to everything if you were interested in, buying and making your own small proof of concept. But it ends up kind of looking like this before everything is put into the enclosure. So this is our valve. This is our solenoid that is controlling the on-off. This is the note card and the note carrier, which are actually being the brains of the operation. And then we have a few extra connectors to make sure that the power is the correct ampage as it's turning on and off and measuring the flow rate. So this is what it looks like when it's all assembled, put together, sealed inside of the container. And as TJ said in his previous one, there is a web application that goes with it. So this is where you actually control all of the changes as well as keep an eye on your valves. So as you can see here, we have fleet controls, which are the fleet environment variables that I was telling you about that are present in the Notehub project. We have flow frequency monitoring. We have alarm settings, which can easily be changed, and those changes will be pushed to that Notehub project from this dashboard. And then we also have individual controls. So if you have potentially different valves that have different alarm settings that they need because they're larger, smaller, what have you, and they need more frequent monitoring, you also have the ability to do that. So you can name each of your devices, which is all done through Notehub. You can change the monitoring interval for each individual device, and you can change the alarm setting. And as you can see in this screenshot, we also have the ability to open and close the valve remotely, which is pretty sweet. And a couple of them actually have alarms going off, which is why you see this little red arrow and arrow pointing up. And when you hover over it, you'll get a notification like this is exceeding the current maximum for this particular valve. So to show you all of that in a real example, I filmed myself using my little monitor. So here's an example of it. As you can see, I have the valve monitor up on my computer. This is just at my kitchen sink. Here is the entire hardware and firmware project all bundled up together. And here is my little valve, which is where the water is going to be handled. So you can see here, we can update the flow monitoring frequency if we want. We're going to set it pretty low. And we have some alarm settings for the fleet. And we also have alarm settings and monitoring frequency for this particular device. So as you can see, I just opened it and we can see that the valve state is opening and it actually starts to push the water through pretty quickly. So that is an actual, real-time change. And then I let the water run for a while and eventually we see that an alarm comes up. And this is because the little pump that I'm using is so small, it's not able to really register how fast the water is being pushed through. So it's saying that the water threshold is below what it would expect it to be. So we can go ahead and clear that alarm after we've hovered over it for a little while. And now I've let the water run for some time and I'm actually going to turn the valve off. So once again, I'll toggle it and we'll see that the valve state will change to closing. And we see that it actually stops running water right at the very end. So that is essentially what this project is all about. And if we go back over to GitHub, we can see that this is another example of not even having to think about how the data gets sent to our project or gets sent to Notehub. It just makes the valve turn on, it makes the valve turn off, it changes the name of the valve if you need to potentially put it somewhere else. It lets you change the flow rate monitors. It lets you get alerts on if something is above or below an expected threshold. And it is pretty simple. So this is all running with very easily accessible code. There's firmware, there's the web app, there's the hardware all laid out in diagrams. So hopefully, you're again seeing how the connectivity portion is not even something we need to worry about. It's really how do we understand this data and make it useful to our users and to ourselves when we're viewing something like this dashboard. And with that, I will turn it back over to Hayden for his last machine learning demo.
Thanks, Paige. So this one is a car detector. So this is a little bit of machine learning, computer vision, using a couple other services. And it gives you an idea of how you can incorporate Blues products with some of these other machine learning services. Specifically, we'll be using Edge Impulse, which is a fantastic tool for training machine learning models that run at the edge and IoT devices and things like that. And also it uses an OpenMV cam. So here's my jury-rigged setup. If you can see this, this is an OpenMV cam. So it comes with a camera and a lens and a little STM32 that runs MicroPython, which is a very stripped down version of Python that can run on microcontrollers. This is just a wood shim that I was using to mount the thing, which I'll show you in a sec. And this is, again, a note carrier A with a note card on it. And they're just connected to each other via I2C. And I also have the note carrier providing power to the OpenMV cam. So note carrier A, good choice if you have a non-Feather MCU that you're targeting. All right, let me share my screen again. So this is the page for the car detector app on GitHub. Should look pretty familiar by now. Again, we have our build materials, in this case, note carrier A and the OpenMV Cam H7. We're also going to use OpenMV's IDE to develop the model for this for this project and also upload the code to the MCU. There's a close-up of what that OpenMV cam looks like. It exposes some pins for doing GPIO as well as I2C, receiving power as you saw there earlier. Here's my mount again. And then I just put this out on my porch, the top floor of our little townhouse. And I've got a pair of helping hands here. To electronics enthusiasts might be familiar with just holding on to that thing. And then I trained the lens on this intersection by my house. So the idea with this project is that we should be able to detect cars passing through the intersection. And you could use that to produce traffic data. You could use it as some sort of security system. There's a number of use cases for this kind of thing. But essentially, generically speaking, it's an object detection problem. So you could use this to detect any sort of object. You would just have to train your model accordingly. But the ideas here are generalizable. And there's the OpenMV cam hooked up to the note carrier. So when we're actually building this model, we use the OpenMV IDE to collect data. And so this just involved me sitting in the hot sun outside for several hours and just snapping pictures using their interactive IDE provided by OpenMV of cars passing through the intersection so I could get positive training data. So I did that for a while, accumulated a bunch of samples, used grayscale to limit the dimensionality of the data. Whatever you can do to limit the dimensionality of your data. Machine learning will make the model smaller and run faster, which is pretty important when we're working at the edge here. Here's an example of a positive image of a truck passing through the intersection. This is it zoomed in here, of the region of detection. This is actually the resolution we're working at. So it's a really small snapshot of that intersection. But nonetheless, it's able to generate positive detections just with that small region. So once you have all that data collected, Edge Impulse, again, a partner of ours, has excellent tutorials for how to train their object detection models using your custom data set. In this particular case, we're using a model they developed, or an architecture they developed called FOMO, faster objects, more objects. It's based on the famous MobileNet architecture, and it's ideal for running on constrained devices like this. Edge Impulse also provides instructions on how to upload the firmware to your OpenMV cam. The two of those companies have a partnership as well, so they integrate nicely with each other. And then we just have a little bit of firmware that publishes notes to Notehub every time there's a positive detection. So what is a positive detection? It depends on what you set an environment variable called the confidence threshold to. So the model will produce a value between 0 and 1 that indicates its confidence that a car is in the intersection. In this case, I set the confidence threshold to 94%. So anything greater than that is a positive detection. Go back over here. And so the notes.
Hey, Hayden, I'm so sorry to interrupt you. Just being aware of time, we have 2 minutes left in the hour.
Yeah.
Is there anything final to wrap up?
TJ?
Yeah, I'll drop a few links in here in the chat. Just wanted to thank everybody for coming. If you do have any questions, I'm going to drop a link to the forum in there as well, so you can ask them there.
Awesome. Yeah, Hayden, please finish your last thought, and then everyone else can drop questions in the chat, and we'll make sure to get Blue's contact information in there.
Yeah, let's go ahead and just skip to the video. This will tell you all you need to know. I'm just going to bring this over here. It's just a quick little video of this thing in action. So this is way zoomed in. That's why it looks so blurry. But you'll actually see the detections coming in. See, it detected that car, and there'll be a couple more that come through. And it'll publish the time of detection to Notehub. Then you can do whatever you want with that information. But that's pretty much it.
Awesome. Thank you so much. I see some questions coming in the chat. I want to be on top of everyone's time, and if the Blues team could maybe take some of those questions and answer them offline, I'm happy to send around everyone's contact information, and we can go from there. But other than that, any final thoughts from you all?
No, just wanted to thank everybody for coming. I just dropped a link to our forum. That's the best place to ask questions. Maybe you're watching the recording of this or have something later. We monitor the forum, and it's a great place to reach out if you want to talk about anything.
Awesome. And that forum link is discuss.blues.io, and I'll make sure to put that in the session description as well. Yeah, and thank you all so much for the wonderful presentation, and for everyone who joined us online. As a reminder, Riot hosts these Lunch and Learns weekly on Wednesdays at 1 p.m. Eastern Time. You can find a list of these Lunch and Learns on our meetup page where you registered, as well as on our website. This will be posted to our YouTube channel, and we hope to see you all again. Thank you.
Thanks, everybody.
Thanks.
Thanks for having us.
Bye, everyone.